Welcome to today's deep dive. Anyone building out a commercial AV matrix knows, like, the absolute nightmare of bandwidth limit.
Oh, it's a huge headache.
Right, you're trying to push pristine 4K video across an enterprise network, and the infrastructure just bottlenecks.
Yeah, standard networks just aren't built for that kind of payload.
Exactly. So today, we're looking at a piece of hardware that claims to crack that problem. It's the Atlona HW-OMNI-E4111 OmniStream AVoIP encoder.
Quite a mouthful, but a very cool device.
Yeah, it is. We're pulling specs today from a product page over at HDTVSupply, which, by the way, has a 4.7 out of 5 customer score.
That's a really solid rating for AV gear.
It is. So our mission for this deep dive is to basically look under the hood. We want to figure out exactly how this thing moves heavy 4K video over standard gigabit Ethernet, without choking the network or introducing lag.
Well, the heavy lifting here is really being done by the VCX codec. We're talking 4K resolution at 60 frames per second.
Wow, okay.
And that's with full 4.4.4 color space, completely maintained from encode to decode.
And for you listening, I mean, that 4.4.4 color space is totally non-negotiable in commercial environments.
Absolutely.
Because if you're routing an Excel spreadsheet or, like, complex schematics to a massive boardroom display using a compressed 4.2.0 signal, the text just gets fuzzy.
Right. It's unreadable.
You really need that full color bandwidth for crisp presentation data. But how is the VCX codec pushing that uncompressed level quality without completely destroying the network traffic?
It all comes down to extreme compression efficiency. Basically, VCX mathematically compresses that massive data payload into a stream that's actually manageable by standard gigabit pipes.
Okay.
And it does it so cleanly that the presentation remains completely artifact-free.
So no blocky pixels when the image moves or anything?
Exactly. No blocky pixels at all. And remarkably, it processes this encode in less than a single frame.
Wait, really? Less than a frame of latency?
Less than a frame.
I mean, think about being at a massive live concert. The giant IMAX screen has to perfectly match the singer's lips. A delay of even a few frames would totally ruin the illusion.
Yeah, that's exactly why this speed is so crucial. The video hits the screen exactly when the audio hits the speakers.
Okay, so having a perfect 4K picture is fantastic, obviously. But how does this thing handle sending that massive file over a standard network without causing a bottleneck somewhere else?
Well, that's where the real network engineering challenge comes in.
Right, because pushing a heavy 4K feed over the network is one thing. But what happens when an older 1080p preview monitor in the control booth asks for that same stream?
Usually, it's a disaster. The network switch takes a massive hit trying to downscale that 4K feed on the fly for the legacy display.
Yeah, or worse, you bottleneck the whole system just waiting for it to process.
Exactly. But the Atlona gets around this by using dual encoding engines with independent scalers.
Oh, interesting. So it's generating the heavy 4K feed and a lighter 1080p feed simultaneously.
Right at the source, yeah.
Let me put it this way for you listening. It's like a restaurant kitchen cooking a complex steak dinner for the adults and a simple mac and cheese for the kids at the exact same time.
That is a great analogy.
Right. It sends both out ready to eat rather than forcing the waiter to somehow, chew the food for the kids on the way to the table.
Right.
The heavy processing just stays at the source.
That's exactly it. It ensures every endpoint gets the native resolution it needs without asking the network to do the scaling math.
You just send both streams over the gigabit Ethernet and let the endpoints grab what they need.
Right. Which brings us to the physical footprint. Because packing dual independent scalers and VCX processing into a single box usually means you're dealing with a massive overheating unit.
Yeah, something that just eats up precious rack space.
Exactly. But they've actually managed to condense this into a half-width rack enclosure.
Oh, wow. Just half width.
Yeah, so you can mount 2 of these side by side in a standard 1U space. And it relies on really efficient front-to-back airflow, so thermal management in a dense rack just isn't an issue.
That's incredibly smart, and I see here it's running on PoE, Power over Ethernet.
It is.
Which, honestly, it's like getting your water supply and your electricity through the exact same garden hose. One cable does it all.
It really simplifies things.
Pulling both the high bandwidth video data and the electrical power through a single standard network cable is a huge win for deployment speed.
Plus, it pairs directly with Atlona's HW-OMNI-E4111 decoders. So it basically creates a seamless end-to-end AVoIP ecosystem without needing bulky external power supplies cluttering up the back of your rack.
Okay, so breaking this down for you. By combining the VCX codec for that subframe latency, the dual encoders to eliminate network-level scaling, and a compact PoE design, this encoder seriously streamlines how we build commercial AV systems.
Yeah, I mean, it effectively turns a standard Ethernet network into a high-end, zero-latency video matrix.
Which leaves you with something to think about as we wrap up today. If a compact half-rack box can now instantly send artifact-free 4K video over standard Ethernet cables, what does this mean for the future of traditional heavy HDMI cables and hardwired video matrix
It's
systems?
a great question.
Are dedicated, heavy HDMI switchers about to become a thing of the past? Think about it.